Next we are going to see is about moduli of elasticity. Okay, so in this moduli of elasticity there are basically three types of modulus of elasticity. They are Young's modulus, bulk modulus and rigidity modulus, and this is basically based on the Hooke's law. From Hooke's law we have proved that the stress is directly proportional to strain and provided the deformation is very small. So this is what is a Hooke's law, is it not? And based on this Hooke's law we have this modulus, and there are three types: Young's modulus, rigidity modulus and bulk modulus. Okay, so what are the three types? Young's modulus, rigidity modulus and bulk modulus. The rigidity modulus is also called as shear modulus. Okay, so rigidity modulus is also called as what? Shear modulus. So we are going to see this one by one. So basically what is all this is, we are going to see what is the value of stress and what is the value of strain. So this is what we are going to see in all these three cases. Okay, so stress and strain என்னன்றத பார்க்கிறோம். Stress, we know the formula, which is F divided by A. Okay, so force and area என்ன ஆகும். Then for strain we are going to see with change in dimension divided by the original dimension. Okay, so change in dimension divided by the original dimension. So this is what is strain. Okay, so stress and strain. For Young's modulus we'll be seeing with the length. Okay, and for rigidity modulus we'll be seeing with the angle, and for bulk modulus we'll be seeing with the volume. Okay, so here we'll be seeing with the angle and here we'll be seeing with the volume. So here is the length. Okay, so this is what we are going to see in all these three. So first type is Young's modulus. In Young's modulus, when the wire is stretched or compressed, then the ratio between the tensile stress and tensile strain, that is called as the Young's modulus. Okay, so when the wire is being stretched or it is being compressed, what? The stress by strain. Okay, stress by strain we are writing as tensile stress by tensile strain. Clear? And that is the Young's modulus. So when you are writing this as an equation, we get Young's modulus is equal to tensile stress by tensile strain or compressive stress by compressive strain. Okay, and this tensile stress we are writing as sigma t, and this we are writing divided by epsilon t, because we are considering this value to be tensile அப்படின்றதுனால we are writing as summation t divided by epsilon t. Okay, and if you are writing for compressive, it is summation c divided by epsilon c. Okay, and the unit for the Young's modulus is same as stress, because strain has no unit, and so what will be the unit? It is stress, and since the strain has no unit. Okay, and what is the SI unit? Is nm power minus 2, or the other unit is Pascal. Okay, so this is a unit for the Young's modulus. Clear with this? Okay, then next we have the bulk modulus. So bulk modulus is given by, it is defined as a ratio of volume stress to the volume strain. Okay, so volume stress to the volume strain. Instead of volume stress, here it is written as normal stress divided by volume strain. Okay, so normal stress divided by the volume strain, that gives you your bulk modulus. Okay, and the normal stress, the formula is what? Del, which is equal to sigma, which is equal to F divided by A. F by A is a formula. Instead of A, we are writing here as del A, because change in area. What is F by A? That is also equal to the pressure. Okay, so del of P. And volume strain. Okay, so change in volume divided by the original volume V. Okay, and the bulk modulus is equal to what? This divided by this. Okay, and so we are writing as sigma n divided by epsilon v. Okay, so what is the value of sigma n? Is del p divided by this value. So the value of this summation n, which is del p divided by this epsilon, is what? Del v divided by v, is it not? Now here we have a negative sign. Yes, so that negative sign indicates that the equation, the volume decreases. Okay, so the negative sign in the equation indicates that When the pressure is applied, the volume decreases. Because of the decrease in the volume, we have the negative sign in the equation. Okay, and the material can be easily compressed if it has a same value of bulk modulus. So if it has a same bulk modulus, then the material can be easily compressed. In other words, the bulk modulus measures the resistance of solid to change their volume. Okay, for example, the gases can be easily compressed. So when you consider gases, it can be easily compressed. Okay, so this is what about a bulk modulus. Okay, and the unit for the bulk modulus is also same as the stress, and so its unit is n m power minus 2. Clear? So next we have the compressibility. The reciprocal of the bulk modulus is called as a compressibility. Okay, so bulk modulus is represented by the letter k. Yes, and the reciprocal of this bulk modulus is equal to the compressibility. Yes, and it is defined as fractional change in volume per increase in the pressure. Okay, so it is given by the change in the volume, because what is k is k, just now we have seen, which is del p divided by del v divided by v, is it not? And so inverse of this we get del v divided by v divided by del of p. Okay, and so this we are writing as change in volume per unit increase in the pressure. Okay, and so this gives your compressibility. Okay, so clear with what is compressibility? So compressibility is the reciprocal of the bulk modulus, and it is given by C is equal to 1 by K. So minus of epsilon V by sigma N, which is del V by V del P. Okay, gases have the more small value of bulk modulus. So when you see here, the gases will have the bulk modulus value to be so small when compared to the solids. Okay, so when the bulk modulus is small, the compressibility is high. So the gases have large value of compressibility. Okay, clear? Then last is we are going to see about rigidity modulus. So rigidity modulus is defined as the rigidity or shear modulus, and it is given by shearing stress divided by shearing strain. Okay, shearing stress by shearing strain. Instead of shearing strain, we can also write it as angle of shear. Okay, so shearing stress or the angle of shear. So what is the formula for stress? Which is force divided by area. Okay, and so we are writing as tangential force divided by area, which is f of t divided by del of a. Then what about this shearing angle? That can be written as theta alone. Okay, so shearing angle, which is theta. Now substituting this value, so ft divided by del a divided by this x by h. Instead of x by h, we are writing as theta. Okay, so this value gives your shearing value. Okay, so this is the rigidity modulus. Clear? Okay, and this equation implies that tau is proportional to theta. Okay, so tau is proportional to theta. Tau is what? The torque that is proportional to the shear angle, which is theta. And here also the unit is n m power minus 2, because strain has no unit. Clear? Thank you.